We're going to use a calculator, TI-Nspire today. We are going to first think about this thing called logs, right? Are they useful for anything?
No.
pH.
Oh yeah, negative hydrogen ions.
Okay, so today we're going to look at the applications of, so a big indice application is compound interest. So we're going to look at that today and we're going to see a magical pattern. All right, so go to lists, click on list spreadsheet. Okay, we're going to put in some time. So let's go with, do you remember like the time periods? So what could be compounding period? Could be 1 year, or it could be, what did you say? Months? Oh, you said months. So it could be 12 months. Could be compounding every
52 weeks.
Every week. It could be compounding every day. It could be compounding every hour or second. I don't know, whatever it is. I don't know. 365 times hour. Oh, look at that. It could be compounding every hour. So let's say we put in $1 into the bank. It's a compounding bank, and you get 100% back. Best bank ever. Okay, so let's do the compound interest. First, you do the principal. Our principal is $1. So in your calculator, $1. 1 plus, what was the back, the percentage back? 100, so it's 1. It's 100%. Now, what do we do with the time factor in the equation? We divide. And what's the cell for years? A1. You get the gist. So we're doing to the power of the time, which is 1 year. Okay? So principal times 1 plus I over t to the power of t. Okay, and what do we get? 2. Makes sense. You put $1 in, you get 100% back, so you get $2 after a year. Okay? I want you to now do it for the rest of the time periods. See what pattern emerges. I'll show you. It's in a document. To settings. Go to document settings. And then change the calculation mode to approximate. And that'll give you a decimal instead of a fraction. So hopefully you got that answer as your second answer, 2.61. Alright, so this pattern emerges. It's this special number. It's called Euler. Pronounce it incorrectly. It's Euler. This is where natural logs come in. Okay, this is the E. So just like pi, you guys know pi. Just like phi, maybe you've never heard of phi. It's called the golden ratio. Euler's number is another number which is common across many different things. So it's approximately 2.718-ish. Okay? So this is what we call a natural log. So if you ever see a log without a base, you know what I mean? It's a natural log, okay? So if we put e into the log, what's the answer?
Science.
1, okay? So the opposite of natural log is just e to the power of answer. So if it's log e x, the opposite is e to the x. Okay, that's fine. Now you know. Okay, so this is pretty much where calculus comes in, or the rate of change, a limit where n is going to infinity. So this is where the compound interest is happening. See how that formula looks very familiar to compound interest? So E is equal to this special compound interest formula. Okay? So it's irrational. You can see it has like a non-repeating, that's what I was thinking, non-repeating decimal. Irrational number. So pretty much what I just showed you before. So if you have e to the x equals 2, you can write log e2 equals x. Okay?